the first video for sample exam number 2 for Math 107. This first question is a simple radical equation, and I think I give you a couple things in the actual exam. I'm changing them all the time, so I forget what I put in there for each class. But the idea is you're given an equation, and this is what you're given right here, is a relationship, in this case, between the height of a lookout tower and how far you can see in D. The 1.4 changes everything from, feet to miles, and whatever other numbers need to be changed. But that's a relationship between the distance that you can see on a lookout tower and the height of the tower itself. The question here is, how high does the tower have to be if the observer needs to see 30 miles? Well, D is in 30, so you can substitute that in. When you have a problem and you don't know what to do, the first thing to do is just write down the equation you know. So you could write D equals, I know this, right? 1.4 square root of h. Okay. Now, I want to be able to see 30 miles. That's the distance I can see. So I'll put that into the equation. Now, at this point, when you've done that, things get a lot easier. Okay. So I want to find the value of h that satisfies that equation. To do these, to solve these radical equations, isolate the radical first on one side. So I divide by 1.4 here and 1.4 over here. Okay, so I've got 30 divided by 1.4 equals the square root of h. How do you undo a square root? Well, you square it. And whatever you do to one side, you have to do to the other. So you square both sides. So 30 divided by 1.4 squared equals h. And if you did all the work in this problem and you stopped there, that would be perfectly fine. Again, no calculators allowed on the test. So the idea here is that you're given a formula, then you're given some information, some numbers for the formula. Write the formula down, substitute your numbers in, and then figure out what to do. In this case, with a radical equation, radical meaning it has a square root or a cubed root, something like that in there. Later on, there will have other things, but you've got the square root to deal with. Isolate it. In this case, divide by 1.4, okay, and now to get rid of a square root, you square it, and that's your answer. In problem number 2, the question is, if you want to see twice as far, how much higher would you have to build a tower? I give you this question because I want you to think in terms of these radicals. Not everything is one-to-one. This is an important concept here, so I'm going to go over it. Okay, let's say the distance was 4 times the height. Okay, and that's my equation. This is an easy equation. If I want to see twice as far, so I want the D to become twice as big, what will I have to do to h to satisfy this equation? Whoops, there's a 4 here. Obviously, h would have to become, with this linear relationship between D and h, if I want D to increase by 2, h has to increase by 2. Alright? You don't need any numbers, you just need to observe this. How can I show this is true? Well, what if I divide both sides by 2? Here, I would end up with the original relationship between D and h, so I'd say, okay, that's true. There we go. Okay. Now let's look at a different problem, and this will be slightly different than the one with the tower, but it's an important one. What is the area of a circle? The area of a circle is pi times the radius squared. The problem I'm going to look at in this case, whoops, let me get rid of this. What I'm looking at in this case is, how does A change with R? How does the area of a circle change with the radius? It's not linear. All right, I'll just give you an example right here. Let's say that the radius was 4, then the area would be pi times 4 squared. Right, 4 squared is 16, so that's 16 pi squared. Okay, now let's double the radius and let the radius become 8. Now what's the area? It's pi times 8 squared, which is 64 pi. Okay, what happened here is the radius doubled. This doubled, but the area did a lot more than double. Look at that increase in area. What was does it change? In this case, it's 4 times bigger area. The area, the radius doubled, so it's twice, you're going to change by a factor of 2, but the area changed by a factor of 4. What is the importance of this? The importance of this is in something, like for example, cath lab. Here's your artery, and put some plaque in it. I don't like that so much. Okay, and if somebody wants, and the area that's shown here, that's the area where your blood can flow. Now in the cath lab, you might want to change the radius. Well, as you change the radius, you change the area. But if you change your radius by a certain amount, you don't just change the area by the same amount. In fact, the area goes up by quite a bit. So here's, after the procedure, let's say you just have a little bit on the edge, so the radius might have increased. So the radius went from this small region up to here. So let's say the radius increased by a factor of 3. So the original radius became 3 times bigger. What happened to the area where the fluid could flow? The area is pi times 3r cubed, or squared, I'm sorry. So that becomes 9 pi, and r being the original radius. This is my new area is 9 times bigger, because you would have to square 3r, and the 3 would get squared as well, and that's why it's 9 times bigger. All right, let's go back and think about the tower now. All right, so I'm going to start here. D equals this 1.4 times the square root of h. In this case, it's not squared, it's a square root. I want to see twice as far. So if I change this d into a new value, which is twice d, what do I have to do to h to get this 2 out front? Okay. It's going to, whatever's going to happen has to come in under the square root sign. So it would be 4h, because when I take that square root, I get 2 times 1.4 times the square root of h. You see, because it's under the square root of sign, if I want to double it, I have to increase the height by 4. What if I want to triple it? Then I would have to change the height by 9, because when I take the square root, then I get the 3. What if I want it 4 times bigger? Then the height would have to be 16 times bigger to get me the 4 times distance, to see 4 times as far. You see, because when you take the square root, the 4 comes out, and that's where you would get the 4 on this other side. This is another problem requiring reading. The math is not hard. It's just a careful reading. The bandwidth of the frequency response for electronic equation, electronic equipment, is described by the following equation. The bandwidth is the difference between two frequencies, f2 minus f1. Maybe your bandwidth is what your radio can respond to. Alright? Or maybe you have a little radio that you take in the field with you, or a CB radio. These would be the two, f2 and f1 would be the maximum and the minimum frequencies that it can pick up. Right? And so that's your bandwidth. And now if you don't even know what this means, you can say B equals f2 minus f1. Then there's something called a center frequency, which is the square root of f1 minus f2. Alright? So now you're given these two equations, and now you're given some information. The center frequency, f0, is 995, and the high frequency is this. Find f1 and find B. Alright? So it even tells you the order to do it. You want to find f1. Well, again, you aren't sure what to do, so you write down the equation that you do know. You know that f0 equals the square root of f1 times f2. Okay. I know that f0 is 995. And what else do I know? I've got an f1 here, and it's multiplying 3300. How do I solve for this? I need to get rid of the square root sign, so I square. Again, both sides. Square this side and square this side. You can work these numbers out or not on the test. If you don't want to, you can write 995 squared. Now the square is going to take away the square root sign. So it's f1 times 3300. Isolate 3300. That gives me my F1. So F1 is, in this case, 995 squared, and I wouldn't waste time working out that 3300. There you go. It turns out to be an easy answer, but usually they are on the test. But if you don't want to work it out, that's okay. All right, now B, let's say it's so easy that you can work it out and find it's 300. Then B is going to be F2 minus F1. Again, if you're stuck, write down the equation you do know, which doesn't hurt to write that down anyway. Then put the values in. For the rest of the problem, after you find what B is, realize that all these frequencies are in, okay, so we have 3000 hertz. Okay, so B is, can you express that in kilohertz? Remember, kilo means 10 to the third. So I can move the decimal point 3 places over here, then I will get kilohertz. 3000 equals 3 times 10 to the third, again that's hertz. It becomes kilohertz when I replace the 10 to the third by kilo, or that's 3k kilohertz, and then you can just write a lowercase k for the kilohertz.